Right, in this one we're going to look at a bit of long multiplication. Okay, I'm going to show you three methods, they all work, so you choose the one that you prefer. First one, we're going to do the box method, so I'm going to draw a box over here. Okay, and there's my box. Now, I'm going to split it into three columns because I've got 173, so three columns, 173. Now we're multiplying by 26, so I'm going to have to split it into two rows, 20 and 6. Now all I'm going to do in each of these boxes is I'm going to multiply the numbers, a bit like coordinates. So 20 times 100, 2,000. 20 times 70, not quite so easy, but 2 times 7 we know is 14. Chuck my noughts on the end. Okay, 20 times 3, nice and easy, 60. Now we're going to multiply by the 6. 6 times 100, nice and easy, 600. 6 times 7 is 42, so 6 times 70 must be 420. And 6 times 3, 18. Now I've got all of these numbers, I need to add them up. So 20 times 100 is 2,000. We've got 1,400. We've got 60. Make sure you get the place value columns nice and lined up, makes it a lot easier to add up. We've got 600, we've got 420, and we've got 18. All right, and I'm adding them up. Okay, so 8. All right, there we go, nice and easy. 1 add 2 add 6 is 9. 4 add 6 is 10, add another 4 is 14. So we put the units there, we're going to carry the 1. 1 add 1 add 2, 4. 4498. Now I'm going to show you the Chinese method, all right, which is really useful when we come to multiplying decimals. All right, so it might be worth you having a go at this, even if you don't really like the look of it. Okay, once again I'm going to split to 3 columns and 2 rows because I've got my 173 and 26. But this time with Chinese multiplication, I need to split the boxes up with diagonal lines. Okay? There we go. Now when I multiply my numbers here, I'm going to put the tens here and the units here. Right? That's very important, and it's sort of this bit where we do the carrying like we had to there. So 2 times 3 is 6. Now 6 units, 0 tens. All right? 3 times 6 is 18. 1 10, 8 units. 2 times 7, 14. 2 times 1, 2. 6 times 7, 42. And 6 times 1 is 6. Now this is the clever bit. All right, we're going to add up along the diagonals. Okay, and that's essentially what this bit is. Okay, so along this diagonal I get 8. Along this diagonal, 6 add 1 add 2 is 9. 0 add 4 add 6 is 14. Once again, I put the units there, carry the 1. I always put it over there. All right, so I do that a little bit bigger. There we go. 1 add 0 add 2 add 1 is 4. Same answer, 4498. That's always a bit reassuring, to be honest. Last one, this is the traditional method, all right, of long multiplication. I'm going to put it something like this. 173 times 26. All right. There we go. Now, first of all, I'm going to multiply through by the 6. 6 times 3 is 18, and this is where it gets a bit nastier because I'm having to carry. So I'm going to put 1 in a slightly different colour there. All right, now I've got to carry 6 times 7, 42, but I've got to add on the 3. Add on the 1 to make 43, and I'm doing it in the wrong colour. There we go, 43, but I need to carry the 4, all right? And this is why I'm not quite so keen on this method, but like I say, it's taught in schools, all right? You'll need to know how to do it. 6 times 1, add on the 4, 10. All right, now I'm going to multiply through by the 2, but it's actually 20 I'm multiplying through, so I need to put a naught in the units column because I'm multiplying by something in the tens column here. So 2 times 3 is 6. 2 times 7 is 4. Carry the 1. All right. And then 2 times 1 is 2. Add on the 1. And I've gone wrong somewhere, I think. Yeah, nice. No, I haven't. There we go. We get 3. All right. I now add up. All right. Ignore the pink ones. You've already dealt with them. 8 9, 4, 4. Fantastic. There's 3 methods. Personally, I like that one, but you use any of them, they all work.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.